Hello everyone, this is grade 6, module 6, lesson 15 problem set. Number 1 says the box plot below summarizes the maximum speeds of certain kinds of fish. A says estimate the values in the 5-number summary from the box plot. So I'm going to say that the minimum or the lower extreme is 35. I'm going to kind of guess that the lower quartile or quartile 1 is, I'll say, if I bring it down, it's about there, 39. The next one looks like maybe 42 is the median. This one's like right about there. So maybe 48 for the quartile 3 or the upper quartile median. And then the max kind of right in there-ish. And I'll say 68. As long as your numbers are similar or close to that, you should be all good. B says the fastest fish is the sailfish at 68 miles per hour, which is good because that's our maximum, followed by the marlin at 50 miles per hour. What does this tell you about the spread of the fish speeds in the top quarter of the box plot? Well, it's telling me that quarter 3 is about at 48. So all but one of the top quarters are bunched between 48 and 50. So this top quarter percentage, because this is broken apart by quarters, so 25% lies in here, 25% is here, 25% is here, and then this whole last stretch is 25%. But we know that there's only one value after 50, and that's right up here, the fastest fish, which is the sailfish. So 25% of the data falls within 48 to 50 because only one piece of data comes out to 68. And I'm going to put my statement right there in the center because there is not a whole lot of room that they're giving us for this. C says use the 5-number summary and the inner quartile range to describe the speeds of the fish. So the inner quartile range is going to be 39 to 48, so I need to subtract that. And I get 9, so that's the inner quartile range. So that's going to help me a little bit with describing this. I would say when I describe this, the fish speeds vary from 35 miles per hour to 68 miles per hour, which we can see because that's our minimum and our maximum. The inner quartile range is 9 miles per hour, which we have right there. The middle half of the spread, so the middle half of the data, not the middle of the data, the middle half of it, is between 39 and 48. So half of the speeds are less, we would say, than 42 because of the median. So half of the data is less than, the fish can swim less than 42 miles per hour. Half can swim higher than 42 miles an hour. So that's more or less what I'm doing to describe this, is just making generalizations or statements based around the data. So there's my statement right there. Now let's move down. We have 2, 3 left, so let's look at 2. Suppose the inner quartile range for the number of hours students spent playing video games during the school week was 10. So the inner quartile range, meaning the middle half of the data. What do you think about each of the following statements? I'm not going to write these in or type these in, but we'll talk through them. About half of the students, for A, about half of the students played video games for 10 hours during a school week. So when I read this statement, I know that the inner quartile range is 10. I'm going to say that this may not be correct because we know the width of the interval was 10. But we don't know where it starts and where it stops. And it would help to have other data points like the lower quartile or upper quartile, or even some extremes, minimums and maximums might help us out. So that's kind of a generalization. B says all of the students played at least 10 hours of video games during the week. Well, again, this may be correct or it may not be correct. I'm going to say it's probably not correct because we don't know enough of the data. We don't know what the lower or upper quartiles are, and we know that the width of the interquartile range is 10. So C says about half of the class would have played video games from 10 to 20 hours a week, or from 15 to 25. I'm going to say this could be right, because if we're saying half between those would be my lower and upper quartiles, meaning I can subtract those two to get 10, and I can subtract these two to get 10, which is my interquartile range, which we know in our statement here is 10. So this could be correct because the interquartile range can be calculated. So that's the type of data that we actually need to answer this question is, what are the quartiles? So let's go to 3. Suppose you know the following for a data set. The minimum value is 130. The lower quartile is 142. The interquartile range is 30. Half of the data are less than 168, and the maximum is 195. So I'm going to skip A, and I'm going to go right to B to help me out with this. So I got to sketch a box plot. So I'm going to put 130. The lower quartile is at 142. The interquartile range is 30, meaning 172 will get me my upper quartile. Half of the data is less than 168, so 168 is going to tell me that that's about the median, and the max value is 195. So there are my 5 pieces of data, and they gave it to me all except for this one, which I had to take my lower quartile and add 30 because the distance between the lower quartile and the upper quartile is the interquartile range. So I added 30 to the 142 to get my 172, my upper quartile value. So now I'm going to sketch this. And I'm not really putting it on a number line. You might need to, but I have my values that I need. So there's my box plot. C says, are there more data values above or below the median? So we know the median is right here. Are there more data values above or below the median? And this is kind of a statement that we should know right away, that the median tells us the halfway point of the data, meaning that there should be equal number of data values on either side of the median, meaning whatever or however many data values are here, there has to be here, because the median is the middle part. Okay, so it's the middle part of the data, meaning if there were, just for an example, 21 values here below the median, there should be 21 values here above the median. So that's how we're answering that part. Let's head over to page 2. Here we are on page 2, and it says the speeds for the fastest dogs are given in the table below. So we have them all the way through. Find the 5-number summary for this data set and use it to create a box plot of the speeds. So they are in numerical order, which is so great because what I can do is just kind of check off as I go. So I'm gonna do the checking off one where I do one above, or one the fastest, one at the slowest, fastest, slowest, and I'm gonna keep checking. And I have to have an equal number of values on one side that I have on the other. And it looks like right here is my median, and that's going to be 30. So I'm going to write it down here, median, and I'll put 30. And now that median of 30 broke my data into two pieces. My upper quartile and my lower quartile. So I can add in two more pieces of data right now. I see 20 is going to be my minimum. And it looks like 45 is my max. So now that I have those in, what I need to do is to find my upper quartile median and my lower quartile median. So let's start with the upper, and I have these values right here. So I'm going to do another check off. I'll do it in red this time. So it looks like it's going to be right here at 36. So that's going to be my, it'll be 36, and that's going to be my upper quartile. And then I'll do the same thing with my lower. And I'm going to get right here to 28. And notice that I have 1, 2, 3 on this side, 1, 2, 3 on the other side. Same thing with my upper, 1, 2, 3, and 1, 2, 3. So I have 28 as my lower quartile. So now it says I can draw this, but those are my 5 data points. So if I were going to draw it, it'll look kind of like this. Not necessarily exact, but I'm putting it right over top. So that's my box plot. Then it says, why is the median not in the center of the box? The median's not in the center of the box, as you can kind of see. And there's a couple reasons why this is. And the first one is because a quarter of the data we can see is between 20 and 28. So that's the first quarter. The next quarter is between 28 and 30. That's a very small set range of numbers, 28, 29, and 30, where a quarter of the data is. So half the data is between 10 numbers, 20 to 30. The other half is between 15. And we can even say this second quarter right here has only a range of 2. To the third quarter, we have a range of 6. So it's showing that a lot of the data is close, and a lot of it is close towards the slower speeds, or the beginning or smaller numbers. Part C is going to tell us to write a few sentences telling your friend about the speeds of the fastest dogs. Well, half the dogs run faster than 30 miles per hour. And then we have to look at, you can start getting specific with the names of some of the fastest dogs up there. But I'm going to leave that one up to you. So thanks for watching. Hope this helps, and good luck on the rest of your problem set.